Geometry, section 11.5, volumes of pyramids and cones. Just one formula. V equals 1/3 BH, that's capital V for volume, is equal to 1/3 capital B, that's a base. I know we've talked about that in a couple of different sections. Area of a base, a two-dimensional area, and then times the height of the pyramid. Okay, and what you need to realize is for each of these problems, pretty much, you're going to be having to figure out what that B is. And this is why we did all of what we did in chapter 10 in calculating areas before getting into formulas like this. So if that capital B happens to be a triangle and we know the base and the height, as in lowercase b base, a length, and the height, well, 1/2 BH can go in there. If it's a hexagon, then it might be 1/2 apothem times perimeter. And your formula would be 1/3 times 1/2 apothem times perimeter times h, the height of the pyramid or cone. If it's a cone, then as we've said before, that's a round pyramid, and pi r squared is going to go in there for b. Okay, so this is going to be one of the main challenges for today. And let's look at some examples. Find the volume of a square pyramid with base edges 15 centimeters and a height of 22 centimeters. All right, so let me just take a stab at trying to draw that. It's not to scale, but I can get close. Easiest thing to do is just draw a square, something like that. Square with some dimensions on it, right? And then just pick a point and kind of draw up to that point like that. Okay? And it says that it has base edges that are 15 centimeters. So each one of these, all four of these are the same length. And they're all 15 centimeters. And then the height is 22. Now notice it does not say the slant height, right? That's something different. The slant height was something that did this. And that's not what we're doing. We're talking about a height as in simply up and down, straight up and down. Or probably the better way to say that is that it's perpendicular with the base. Something like this. And they told us that that height is 22. The volume is 1/3 capital B base times height. And that capital B base is 15 squared. It's a square, so 15 squared times 22. Use your calculator if you must. I'm going to. And it's 1650, exactly 1,650. Work and answer, and that would be centimeters cubed because it's a volume. And that's what they get to. Now it's just getting a little bit more complicated from here, but not too bad. Notice on this picture, the height is not given. But what is given is what we know to be the slant height, 17. And you can figure out what this is here because it's going to be half of the 16. Everybody realize that? Here you have a square base. This height's going to come right down to the very center of the square. So this length would be the same as it is to that from that point to the other side. You just have to cut 16 in half. We're talking about a triangle that has a leg of 8, a hypotenuse of 17, and then the height is the other leg. So simply h squared plus 8 squared equals 17 squared. And if you solve that for h, you'll find out that h is 15. Subtract 64 from both sides and square root, you'll find out that the height of that is 15 meters, that is, right? So 15 meters is, we're going to need that in our formula. Volume is 1/3 capital B, which would be 16 squared, times the height, which we just found to be 15. So not much difference between this problem and the last one, but that we had to solve for h before we could do this. And again, I'm going to my calculator here, and I get 1,280 meters cubed. Okay, moving on again. They showed a little work on this one. There you go, 1,280 meters cubed. All right, I'm glad they did this. Notice that it's a cone, and notice that it's not straight up and down as in, symmetrical around its height. That does not matter. The height is 11, and we're going to use that. So the formula is exactly the same. Volume is equal to 1/3 capital B, and that capital B is pi r squared in this case, times the height. in which case we're going to plug numbers in. Now, I do think, and I think we mentioned this in a previous video, that what the 6 is pointing at is up for debate. And I don't think that you'll have this kind of confusion in your homework, and hopefully not on any Socratic quiz. But I think some people would say that that 6 is pointing at the radius, and other people would say that that 6 is pointing at the diameter. And I could go with either one. So I can tell you what they're going to do. They're going to say that it is a diameter. And I think the giveaway is the fact that they've drawn all the way across. Okay, so again, we'll make sure that that doesn't happen on assessments, and I'm pretty sure it doesn't happen in the book as well. So you should not be confused beyond what I'm showing you on this example right now. Anyway, the radius would be 3. And the height is 11. Now, they did say in this one, as they often do with round things, as in cylinders, and in this case, a cone, to leave it in terms of pi. So that would be 1/3 of 9 times 11, that'd be 33. And then you just leave pi in your answer. You do all the math that's around pi, 1/3 times 3 squared times 11 will be 33 pi, and it's a volume, so it's still inches cubed. If they said round to the nearest, then you want to go to your calculator and type in 33 pi. Use the pi button, please, and then round to what they say to round to. Okay? Now the last one is similar to this one, so I don't know that I necessarily need to do it, but I want to show it to you because of all the examples that I do in the year, this one makes me the angriest. Let's read it and I'll show you why. An ice cream cone is 7 centimeters tall and 4 centimeter diameter. About how much ice cream can fit entirely inside the cone? Doesn't that make you angry? Would you be angry if you went to the ice cream shop this summer and they just filled it with ice cream right level with the top? It's upsetting. Anyway, the work and answer would be very similar to the last question, except they didn't leave it in terms of pi. Use the pi button, and there's the decimal that they got. So about 29 centimeters cubed.